Hey class, I'm Mr Thornton and I'm going to help you get that C in your GCSE. This lesson, Electrolysis, Part 1, How it Works. This topic was suggested by Shahid Hussain, Oliver Lennox, Ibtissam Adam, Ben 20 Cog and Maria Hunter. Thanks guys. If there's a topic you're having trouble with, then just leave a comment below. I've previously explained the use of electrolysis in the extraction of copper as part of C1, which you can see if you click just here. Now in C2, we need to go into a little bit more detail. Electrolysis is always done on ionic substances. This is because ionic substances are very strongly bonded together. The ions that substance is made of are held together really strongly. And so what we need to do before we can start electrolysis is try and figure out a way to separate them out a little bit. And so there's two key ways that we can do that. We can either take our ionic substance and heat it very, very strongly, or we can take our ionic substance, such as sodium chloride that we get in table salt, and dissolve it in some sort of solvent, such as water. Now when I do this, the ions which were previously bonded very strongly to each other in my table salt, they're now free to move throughout this water. And we refer to the water as an electrolyte. That is, that now it's salt water, now there's ions dissolved in it that can move around freely. That is what an electrolyte is. Now because it's sodium chloride, there are sodium ions in here and there are chlorine ions in here, and all we need to do now is give them a way to separate. So all that you need to do is take a couple of electrodes, stick them into your solution or into your liquid, and apply an electrical current. The positive ions will be attracted to the negative electrode, and the negative ions will be attracted to the positive electrode, and they'll separate out. In this sense, it's a little bit like static electricity. You just need to remember that the opposite charges attract. So positive attracts negative, and negative attracts positive. We call the positive electrode the anode, and we call the negative electrode the cathode. And it's really, really easy to remember the names of those. As the Hitchhiker's Guide to the Galaxy says, don't panic. This helps you remember which electrode is which. We've got Pa for positive anode and Nc for negative cathode. It's all very well knowing which electrode's which, but how do you know which ion goes to which electrode? Well, actually that's easier than you might think, because in the exam, on the back of your periodic table, you also get given data about the different ions. I'll leave a link to this document in the description below. If you look at this, you will see that every single one of the metals, every metal in the periodic table which you need to deal with is always a positively charged ion. You also get hydrogen in here and ammonium in here. But basically, look for the ion which you need and it should be in here somewhere. So all of the metals, they're all positively charged. If you're doing higher tier, then you're going to need to do electrolysis half equations, and I'll cover that in another video. But if you're just doing the foundation tier, you don't need to worry about whether it's, say, a plus for hydrogen or sodium, or whether it's a 2+ for copper or magnesium. It doesn't make any difference. All you need to know is which is the positive one and which is the negative one. So all of these positive ions, they will all be attracted to the cathode, and all of these negative ions, they will all be attracted to the anode. You do need to know a couple of technical terms related to what's going on here. When a positively charged ion finally reaches the cathode, it gains electrons, and this turns it from an ion into an atom again. We say that it has now been reduced. That is, it's gained electrons. If the opposite happens, if a negatively charged ion reaches the anode, then it loses some of its extra electrons until, again, it loses that charge. And we say in this case it's been oxidized. Now this may not have anything to do with oxygen. Oxygen may not be involved at all. So the names can be a little bit confusing. But there's an easy way to remember this as well, and that is oil rig. Oxidation is losing oil. Reduction is gaining rig. So if it loses electrons, it's been oxidized. If it gains electrons, then it's been reduced. That covers the theory behind electrolysis. In part 2, I'll look at some practical applications and uses. I hope that video really helps you. If you want to check how well you understood, then try the snap quiz. The link is right here and it'll also be in the description along with all the other links for this video. If you want to check out my other videos, then click right here. If you want to download the free app I've made to help you with your revision, then you can click right here. If you want to subscribe to my channel, then you can click right here. Don't forget to leave likes, and if you go to the comments, you can give me feedback and let me know which topics you'd like me to cover next. Good luck in your GCSEs everyone, and thanks very much for watching.